What's up, guys? Hope everything's doing okay. And let's finish this chapter 9, and then we can move on to the application things. Before I'm going through this one, as we all know that the study design for 2020 has been changed and updated with you guys, so please have a look. For our math method, we actually get rid of like the probability for discrete random variables and continuous random variables, as well as the statics problem, basically the sample and population. We not testing you guys for this year. And the next one is for special math. Again, all the statics, just get rid of it. And for further math, the difference is we only learn one module instead of two, okay? And also, because I also teach you guys for physics, so physics is basically changed a little bit. A lot of uh, reduction about the practical investigation, and some part of the waves and the light just not test for this year. So I know this is a tough year, so let's hang there and let's do it. Okay, let's back to our final chapter for let's back to our final sections for our chapter 9, limits and continuity. So this one is not that important for the final year exam, but it's really essential for you guys to understand what's the function we mean by continuous and what do we mean by differentiable, okay? So before that, we have to know the limit. Limit means as A approaches to A, fx approaches P, okay? That is how we write this one, limit. And essentially we just plug number in to get the value, but if we can do the simplification first, we always simplify our answer. Okay, always simplify, then we plug the number in. With such things, we can define is left limit and right limit. So left limit means if we have a number a, we from the left hand side to approach this a, then we call a minus, which is left limit. And if we from the right hand side to approach a, it's a plus, then we call it right limit. So for anything or for any functions, if we want to define if it's continuous at a certain point, we need to satisfy three things. So first one is defined as x equal a. Essentially, it just means x equal a, or a is inside the x domain. So a must be in the domain. So second one is the left limit must equal to the right limit. So basically it means the limit at this point is existing. The third one is the limit is equal to the defined value. Okay, so this, I know I'm just saying that it's too weak, but let's just give you example to filling it, how to define the continuous stuff. So let's look at over here. First, we look at some special points. Okay, like this one. This one is my special point because it's defined over here, and there are empty cycle over here. So first, we ask us, the question is, at x equal 1, does this function, or maybe like in this way, x equal 1, is that 1 is in the domain? The answer is yes, because f1 is 3. It's defined on the top over here. So it passed the first condition. Then the second condition, the left hand limit equals the right hand limit. So we approach it from left hand side, we got 2. And we approach to the right hand side, we got 2 as well. So in such case, the x equal 1, the limit is 2, right? So second one, good. And then we look at third one. Third one is the limit must be equal to this defined values. The defined value is 3, but the limit value is only 2. So it fails at the stage 3, which means it's discontinuous. Okay? And then we look at part B. Again, we have two special points, -1 and 1. Then from -1, again, they have the definition. And first stage 1, clear. Stage 2, left limit and the right limit. The left limit is approaching to positive 2, and but the right limit is approaching to negative infinity, or maybe we should say not existing. So in such case, the stage 2 fails. That's why at -1 is discontinuous. This is the reason also the book gives us, okay? And later on, if we keep looking at point 1, again, it has the definition because at x equal 1, our y value is 2. So it's defined. Then secondly, we again look at the left limit and right limit. One is 2, which corresponding to the left, and another one is corresponding to the right. It's 3. So the left does not equal to the right. That's why this is unbounded or it's not defined. Okay, I should say it's not defined. That's why stage 2 fails. Same over here, left limit is not equal to right limit, stage 2 fails. Okay, that's how we prove its continuity. And let's move on to the differentiable. Differentiable is slightly easy because for this one, we just need to know or just need to derivative for both equations and then try plug the numbers in to get the answers. For example, for the function with following rules, fx equals x squared plus 2x plus 1, and then fx equals 2x plus 1. So the derivative is 2x plus 2, and another one is 2. So if I plug 0 into both equations, I got 2. That's why it's differentiable at point 2. And then we think like smoothly, okay? Join smoothly, okay? And for 46, then on the left hand side, I derivative at 2x plus 2. And on the right hand side, I got 1. So my left derivative is 2 when I plug 0 in, and my right is 1 when I plug it in. Sorry, my left is 1, but my right is 2. But anyway, it's not equal, then the function is not differentiable at this point. So there's another thing is if a function is differentiable at point A, and then if function is differentiable at x equal a, then it is also continuous at point A. But the converse is not true. Okay, just make sure you get this idea. The function is differentiable at x equals a, and is also continuous at x equals a. Okay, hopefully it makes sense. And that's it. That is for our chapter 9. And chapter 9 is basically give us a fundamental understanding or fundamental things we're going to use for later chapters. First, they define what is or what do we mean by derivative. So derivative is essentially it's a rate of change, but at a certain point, or maybe I should say instantaneously rate of change, or it's just like average rate of change, and the average time is really small. So in this case, the Q is infinitely small away from P. Essentially, P and Q are overlapping. They become 1 point. Okay, and with this derivative equation, or we call it first principle, then we can got a lot of other derivatives, or maybe we should call the basic derivatives. But this one is important and is build our foundation for later analysis and studies. And this one, of course, is not required to remember and or to memorize because it's provided. But again, from basic ones, we have to know how to apply for chain rule, product rule, quotient rule. These 3 rules to help us find the derivative correctly and plug the number in. If you guys cannot remember that, please refer to my previous videos. I give you guys the final year exam practice and make sure you can know how to use your hands solve them without using the technique. Okay, and the last part is like limit and the continuity and differentiable. This is important when you enter the uni. After you start slowly analyze the more function behaviors, but if only constrained in the high school domain, this continuous and discontinuous or differentiable is not that important in final exam, but it's really worth to know and to understand the smooth and difference between continuous. Okay, smooth it means differentiable, and the differentiable always can apply continuous, but continuous cannot apply differentiable. Okay, hopefully my video is helpful. Please click the like button, and next video we're gonna start to application things. Okay, I guess I see you guys for the next video. Bye bye guys, have a good one.